Okay, well, thank you very much, everyone, for coming. We'll go ahead and get started. Today, we're going to be talking about WinRM, Ride the Adventure. So when I think of WinRM, when I think back to my first experiences of running commands remotely over WinRM and what I thought was going to be 15 minutes and what became several hours, the first word that comes to my mind is adventure. And I don't necessarily mean that in the positive sense of the term. And having talked to several other people who have gone through the same experience, and having talked to some of those people while they were going through the experience, I feel like that's an appropriate term. It often feels like an adventure, and not necessarily an adventure that you want to be in. So what I hope to do today, what I want to accomplish, is bring WinRM down to earth, down to our level. Let's understand it, and let's take the adventure out of WinRM. So a little bit about myself. I'm Matt Wrock. I am one of the primary maintainers of the Ruby WinRM gem. Late last year, we were the first open source implementation of the Powershell remoting protocol. We'll talk more about that in a bit. The WinRM gem, it's the WinRM client that powers applications like Vagrant, Knife Windows, Test Kitchen. And I blog at hurryupandwait.io, so in troubleshooting your own WinRM problems, you may have stumbled upon that. If so, I certainly hope it was helpful. I work for Chef. I've been working for Chef for almost 2 years. Since October, I've been on the Habitat team. One of my focuses is making Habitat work on Windows. I'm not going to be talking about that today in this talk, but if that's something that interests you, it's definitely something that interests me. So please see me. Track me down before the conference ends. I'd be happy not only to tell you about it, but to show it to you. I tweet at mrockx. So let's start off by going deep, actually. Let's go deep into the WinRM protocol. What I want to do here is I want to give everyone here a solid mental model of what happens on your workstation when you make a request to a remote server over WinRM. I want to dispel any myths and any incorrect assumptions that we might have, because to a lot of people, WinRM is just this big cloud. I'm issuing this command, but I don't really know what's happening. And with those incorrect assumptions, sometimes we can lead ourselves down a rabbit hole when it comes to troubleshooting our problems. So let's get started and look. What is WinRM? Exactly what is happening? But at the core, I can tell you what WinRM is. It's a web service. A lot of people don't know that, but that's simply what it is. There's a tiny web server running on the remote machine where you're trying to invoke your command. And then on your machine, there's really just a little bit of code. It's not doing a whole lot. So because it's a web service, all it's doing is it's issuing HTTP requests to that web service, asking it to run commands, open shells. And so that WinRM client, in most of our case, if you're using Chef tooling, that is the WinRM Ruby gem. But it could be maybe you're using Packer. There's a Go library for WinRM. If you're using PowerShell, enter PS session or new PS session, then it's PowerShell itself. But all of these libraries are doing the same thing, and they're all constructing the exact same HTTP messages that are making requests off to those WinRM servers. So let's take a look at these messages. What's the sequence of messages? There's several involved in actually invoking a WinRM command. And what we're going to find is that this sequence correlates very closely to what you and I would do on our own machines if we want to run a command against our own machine. So what's the first thing that you do when you want to run a command on your own machine? Well, the first thing I do is I open up a console. That's exactly the first thing that we'll do with WinRM. We're going to issue a create shell request. We're going to create an HTTP request, send it off to the remote machine. It's going to receive that request, and it's going to do exactly that. In fact, it's going to spawn a process called conhost.exe. So if you're on that other machine, you may see those. You can think of that basically as an invisible console window. It'll also spawn a process interpreter, or a command interpreter, so cmd.exe. And it'll send back to us an identifier, a unique identifier, a GUID, a 32-character GUID, that's the shell ID. And we're going to use that shell ID to run commands on that shell. I mean, we can have multiple shells open, and just like on our own machine, each one is its own environment context, with its own environment variables and so forth. And so the next thing that we're going to do, because what's the next thing that you would do after you open your console, is you start typing and you hit enter. And so the next thing we'll do is we'll issue a create command request. We're going to give it that shell ID because that's where we want the command to run. And inside the create command request is going to be the command itself and all of its arguments. So we'll send that. The remote machine will receive that, and it will spawn that command. It'll invoke that command. It's not going to wait for the command to finish. It's going to immediately return back to us a command identifier. So just like the shell ID, we're going to get a command ID, same format, a GUID. With that command ID, what's the next thing that we do on our own machines after we hit enter? Well, we wait for output, right? We expect some kind of feedback from that command. So we're going to send a receive command, a receive response command. We're going to send in that receive command, the HTTP request that we're sending. We're going to include the streams that we want access to. Now in WinRM land, there's really just there's two streams that we have available to us. That's output and error stream. Well, there's more streams in PowerShell remoting. We'll get on to that in a little bit. But at any rate, so we're going to ask for a request from the server for output, and we're going to get usually you would expect about a few different types of responses from that. So if it was a fast running process, I would expect to get the full output of that response along with the exit code that command exited with. Now, if it was a command that took a while and it didn't give me any output until it was done, I might get next to nothing. I mean, I'll get a response. The output of that response will essentially be empty, and I'll get a signal basically telling me that the command is still running. Now, let's take the scenario of a chef client run. So let's say we're using knife WinRM to execute the chef client remotely. Now, that could take, I mean, it depends on what you're converging on. It could take 5 minutes, could take 20 minutes, could take an hour. So what I would expect to see there in that very first request for response, I would expect to get a little bit of output, like the very beginning of my chef client run, but no signal that the command has terminated. And so what the WinRM gem will do, it's just going to keep pulling that server for output, and it'll keep taking that output, returning some structured information back to the application that's using the WinRM gem. So if you're using knife WinRM, that would be the knife Windows gem. It's going to take that and return output to your screen. And it's just going to keep doing that until one of the responses, that last response that we get back from the server, includes a signal telling us that the process has exited, and it will also give us the exit code of that process. Then there's a termination signal that we can send. So let's say if we don't want to wait for that command to finish, you can kind of think of this as a remote control C. So again, these are all of these are just simple HTTP requests. The WinRM gem or whatever your WinRM client is doing is just basically constructing strings that form these messages, and the WinRM web server is doing all the work. So the last message is the close shell. And so this closes the shell. It's basically the equivalent of, on your own machine, if you were to hit the upper right-hand X in your PowerShell console, and that closes out the shell and basically kills off any processes that shell had open. And that's particularly important to do in WinRM, because one thing about WinRM, unlike on our own machines, is that it has, in the WinRM configuration, there's all sorts of quotas that are specified. So one of those quotas is the maximum number of shells a user can have open. There's also quotas that govern the maximum amount of memory that a shell can hold open, and the maximum number of processes that can be running simultaneously. All of these quotas are configurable. But to be one thing to be aware of is that the version of Windows that you're on will often determine the default value of that quota. So if we take our shell, for instance, if I'm on Windows 2008 R2, I can't have, by default, I can't have any more than 5 shells open at a time. Now that might not be a problem for you, let's say if you're in a test kitchen run. Test Kitchen will open up a shell, it'll run several commands within that shell, and it'll close it. And that's the efficient way for applications to use WinRM, is to run as many commands as they can in the same shell, because it literally takes seconds to open up a shell. However, Vagrant, I've talked to people who have multiple Vagrant plugins, each of which performs some kind of provisioning operation that takes up a shell. If you're on 2008 R2 and you end up with over 5 shells, and your Vagrant up is not going to be it's not going to be very successful. So let's take a look. So don't, if you can't even see this or read this, it's fine. I include this slide because I want people to see what one of these requests actually look like. So this WinRM service, the web service, it's following a SOAP protocol. If you don't know what SOAP is, that's fine. It was very popular back when WinRM was created back in 2005. You still see them today. They're not nearly as popular today, and all of this text is one of the reasons why they're not so popular. It's known as being a very, very verbose XML format. Most of this XML really has no interest to us as humans. What is interesting to us here, so this is a create command message, and about 4 lines from the bottom. So what this is doing, this is deleting a file. So we see the command, it's del, the delete command, along with all of its arguments, and then including the actual file that it's deleting. The other thing just of interest is we see our shell ID in here. So right smack dab in the middle of this message, the shell ID, the UUID, that's the shell that this command is saying it wants that command to run inside of. So this is what's actually going across the wire in WinRM. So some of you might be thinking, especially some of you who use PowerShell on a day in, day out basis and use PowerShell remoting, you might be thinking, oh, okay, so this is PowerShell remoting. Well, actually, no. PowerShell remoting is its own specification. It's its own protocol. So let's back up. So about September of last year, the WinRM gem, and so any application that uses the WinRM gem, implemented the PowerShell protocol. I'll get into why we did that in just a bit. But up until that time, all cross-platform WinRM clients, so Go, Java, Ruby, all of those clients used an older protocol called WSMV, the Windows Services Management Protocol extensions for Vista. It was called that because that's about around the time that it came out. So on the server side, it came out around Windows 2008, R1. You can actually run it on Windows Server 2003. It's a much simpler protocol than the PowerShell remoting protocol. So when PowerShell remoting came out in PowerShell 2, which is around 2008 R2, it has a much richer set of messages. There's about 41 different types of messages that you can send with PowerShell remoting. As many of you know who are familiar with PowerShell, you know that PowerShell has several streams. So you got your progress stream, your information stream. WinRM has it only has output or error. So there's all these messages provide a way of expressing that. But the thing to note is that the PowerShell remoting protocol is not exclusive of the WSMV protocol. So the PowerShell remoting protocol actually depends on WSMV. What WSMV does is it defines the transport layer. So that SOAP message we were just looking at, it uses those same messages to embed the PowerShell message in. And it's a much more complicated and basically kind of a hassle to implement because the PowerShell remoting protocol is binary. So basically with the WinRM library, it's creating this byte array and packing all the bits of information in there and essentially rendering it almost very difficult to debug and certainly to look at over the wire. But so why did we go to the trouble of implementing it? I mean, it served its purpose. Other libraries do just fine without it. And so the reason why is because there is a limitation in cmd.exe. So I didn't mention this real quick. So WSMV without PowerShell remoting, that all talks directly to cmd.exe. So that's, cmd.exe, that's the old school Windows command line. And PowerShell remoting talks directly to PowerShell.exe. We've done fine with, we've done fine in cmd.exe. We would just, if we need to run PowerShell, we just, inside of that, of the old cmd.exe, we just call the actual PowerShell executable and pass it our PowerShell commands. And that's worked for us. But cmd.exe has a very serious limitation. That is, you cannot have a command line that's over 8,096 characters. And you might be wondering, well, why does that matter? I never intend on typing a command that's 8,096 characters. I know I shy away from that myself, but so first of all, so on the one hand, the WinRM gem, it's usually not just sending one-liners. Applications are using that gem often to send scripts, so that is a real thing. But the kicker is when it comes to file transfers. So in Windows land, there is no native SCP. There's no real SCP equivalent. So really what we have to do is we have to use the facilities that WinRM grants to us to transfer those files. So we have to basically write a command that transfers that file. So what does that look like? I'm not going to get into the nitty-gritty of that, but let me just give you a somewhat inaccurate representation that gives you the idea. Imagine it like basically begin quote, take the contents of that file, end quote, greater than sign, which is the file redirection character, and then a file name. So that's basically what we're doing. We're basically just grabbing that content and creating the file. Well, if that file is around 8K or more, that's not going to be a very complete file. So what we've done historically in WinRM is we've chopped up that file. And I'm not going to get into the details, but with all that's involved in chopping it up and the script that we have to send along with each one of those chunks, really we're limited to about 5K and not 8K. And so imagine trying to transfer a gigabyte file, or forget about a gigabyte, even a moderate file of like 10, 20 megabytes. That's actually going to take minutes. A lot of it depends on your network, but on my home Wi-Fi, it takes minutes. If I can use the PowerShell remoting protocol that does not have that limitation, it will just take a few seconds. So that's a serious, it's a major improvement. We can also do things like talk to Windows Nano. I won't get into details on that, but at any rate, so now we do have a full implementation of the PowerShell remoting protocol that the WinRM gem uses. Applications have to tell it to use that. We still expose the old protocol, but if you're using Test Kitchen, all that uses the new protocol. If you're using Knife Windows, you do need to tell it. So Knife Windows has a shell parameter, and you would just give that parameter PowerShell. The default is command, and it will use native PowerShell. So I hope that was interesting. That covers basically what WinRM is, and from a fairly low level, how it behaves and how it works. So it's just a web service. But the question that some of us might really be wondering is, why the heck can I establish a WinRM session? Come on. Why is it so difficult? I was able to SSH 50 trillion times yesterday, just without a problem. So let's answer this question. And what I've found is that in the vast majority of times, you can categorize the answers to that question, why can't I connect, into two categories. The first category is it's a network connection problem. So there's something sitting between you and that WinRM endpoint, that WinRM server that's dropping the traffic on the floor, or on that server that you're trying to reach, the WinRM service just isn't even running. The second category are authentication issues. You can make it all the way to the server. The server is listening to you. It's heard you, but it's basically telling you you're not good enough. The credentials that you're trying to use to log in are not being honored. And what I find is the best first troubleshooting step to take is to try and identify which one of these buckets. And 99% of the time, you will be in one of these buckets. So which one of these buckets you fall in? Because depending on which bucket you're in, that's going to determine a totally different set of troubleshooting measures that you need to take. And I've seen people that end up with WinRM authorization error messages, but then they start troubleshooting, their is it my firewall? Is the WinRM service, flapping? Is it up or down? Well, the fact of the matter is, the good news of a WinRM authorization error means that you made it. You made it to that server. That server listened to you. There's a different set of troubleshooting measures that you need to look at. So let's look at the typical measures for both of these categories. So let's start off with connection troubleshooting. So first of all, how do you even know you're in this category at first? So we've talked about, we know now that WinRM is a web service, right? It's a matter of basically just reaching that web service. So the good news is that a lot of us here now already know the tools and the methods for troubleshooting this problem. I mean, a lot of us here maybe work in a web development shop. Maybe you're a web developer. Maybe you're an ops engineer that supports a web application. You come into work in the morning, after your build has been released to a particular environment. You do a little bit of smoke testing on it. You bring up your browser, and it's not there. And I know certainly I've been in that position. And so now you have to kind of go through these troubleshoots. Why can't I reach my web application? Well, that's the exact same thing with WinRM. It's a web server. And it's not even necessarily an issue of the web. This is TCP/IP. So use the tools that we're all familiar with, basically just to see, can I get an answer from that endpoint on the WinRM port? 5985 or 5986, which are the default. So you know the tools. If you're on Linux, if I'm on Linux, I'll use netcat. On Windows, I like to use test-net connection. If I want to go old school, I'll use telnet. I don't necessarily recommend that, but hey, a lot of us have been using that for decades, so it works. And just check to see if you get an answer. If you don't get an answer, then you fall inside of this category. So if that's the case, the very first question to ask ourselves is the WinRM service running? In other words, can you use those tools actually on the local machine and just point it to localhost and get an answer? And if not, then the chances are very, very high the WinRM service isn't even running. And here we're going to talk again about why the version of Windows, the Windows operating system that you're on, matters. Each version, so let's go back to Windows Server 2008 R2. So 2008 R2 and earlier, the WinRM service is not started by default. So if you've done nothing more than installed the operating system and eliminating any issues with group policy or any provisioning procedures that you have, because I don't know about your group policy. I don't know about your provisioning procedures. I can only talk to the default. So that's what we'll be focusing on. So by default, WinRM is not started on 2008 R2. That's something that you have to do. It's very easy to do. I just open up a PowerShell console and type enable-ps remoting, and we're done. And so what happens there when you do that, so it starts up that web server. It's called, or in WinRM land, it's called a listener. And it's hosted by the WinRM Windows service. It enables the firewall rules on the machine, which is the next thing we're going to talk about. So it allows ports 5985 and 5986 to come in, and then you're good. So you should be able to use those tools locally now and actually get a response. But maybe if you try and hit that same machine on another server in your network, you won't get a response. And that usually is indicative of a problem with the firewall. And so like I mentioned before, when you enable WinRM on 2008 R2, it sets up those firewall rules. Well, it does the same thing on 2012 forward, but there is there's an important nuance. So on 2012 and forward, WinRM is enabled by default. So if you've done nothing more than install the OS, the WinRM service should be running. But because it's enabled by default, it exercises just a little bit more caution when it enables those firewall rules. So, well, on 2008 R2, it pretty much opens up those ports to everything. On 2012 forward, if it's domain joined, then the traffic can come in from anywhere. But if it's on a private network, it will limit the traffic just to the local subnet. So that means that if I'm here in Austin and I want to issue a WinRM command to my 2012 R2 box in AWS, well, we're going to be on different subnets, right? So I'm going to have problems, which means I'm going to want my user data when I provision my machines in AWS, and if I intend on not being domain joined, I'm going to need to enable those, tweak those firewall rules so that it opens it up not just to local traffic. Yeah, did you?
Which version did you say that behavior starts with?
2012.
R1 or R2?
R1, yeah. So once your firewall is all good, the next thing to look at are basically, it's going to depend on your network, but let's take AWS as an example. So security groups. So different networks are going to have different mechanisms. Certainly AWS and Azure have these of allowing ingress and egress rules on certain ports to reach specific instances in your network. So you want to make sure that your Windows instances that you plan on running WinRM have 5985 and 5986 open in your security groups. Otherwise, outside of AWS, or Azure, you will not be able to get to those. So, one more thing to talk about in terms of connection issues, and this I find is the worst one, is proxies. So proxies are finicky. Well, I mean, they're not finicky, but my feelings are finicky towards them. But, well, no, those aren't finicky either. I hate them. But they exist for a reason, I suppose. But so the thing with proxies is when you're having a problem because of a proxy, it is not at all obvious that you're having a problem because of a proxy. So this is one of the ones, like all those other issues, we're able to usually get people up and running really quick. And you'd think that, I've been doing this long enough to come to here, come to the proxy problem sooner. But I mean, I know, it just happened. Like I was just a few months ago, I was going over with a customer issues. We're going back and forth over email, like back and forth, and then, all in all, hours had been consumed before we realized there was a proxy at play there. And so, the issue, one of the problems is that, those tools that we talked about, where you're trying to see if that remote endpoint is listening to a port, a proxy environment will deceive you, because your request will be intercepted, making it seem as though there's something listening on that port. But when that something that is listening responds, it responds with a message that WinRM doesn't know what to do with it, and it's usually like an error message. It's like a just a plain text error message saying, for example, it might say that you haven't authenticated against your proxy. What we used to do in the WinRM gem was give you a nice error about a nil class, but we stopped doing that, and we at least include that output, that HTTP response output in the error, but it's still not always obvious. So a lot of times you just have to know if your environment has a proxy. And here's the other kicker. So once you know that you have a proxy, you may not know how to configure it. I mean, so if you're in a Windows environment and you're comfortable with running native Windows apps, you may think you know how to configure it, because native Windows applications will behave differently from cross-platform applications when it comes to proxy configuration. So while a native Windows application that's using native Win32 APIs to handle HTTP traffic, that knows to look at your WinINet settings, those are the settings that you set in Internet Explorer, basically in the internet connection area, and you throw in your proxy endpoint and port and your bypass rules, and get stored in the registry. So those programs know to look for it, and our usual experience with most Windows programs is by setting those properties, everything just works. Well, not so much with cross-platform tools. And it's not because the cross-platform tools are mean or hate Windows. They have to support not only Windows, but they have to support non-Windows environments that have absolutely no concept of a registry. And usually that logic also is handled by a lower level HTTP library. So in the case of the Ruby WinRM gem, we use a popular Ruby HTTP client library. And it handles all the proxy stuff for us. But almost all of these libraries, in fact, all the ones that I know of, across all the different languages, they all use the same environment variables to detect this information. So don't worry about what's in your internet connection settings. That's not, at least not for WinRM, at least not the Ruby WinRM gem or Chef tooling. That's not gonna help you. What you want to do is set these environment variables. Now, tools like Test Kitchen, Vagrant, even Knife Windows, they might provide courtesy configuration files where you can set those properties, and then they'll set the environment variables for you. So your Vagrant file, your Kitchen YAML, your Knife RB. I'm not going to get into all the different settings, but what I can tell you is that if you at least just set these environment variables within the console that you're using these tools, that should get you properly configured with your proxy. So now let's switch over to WinRM authorization. This is a much smaller topic, and there's really just two things to bang home here. The first thing is you want to be an administrator. The credentials that you're using to log into the remote machine need to be administrator. There's a small caveat there. The PowerShell remoting protocol gets us around that a little bit. Of course, you have to know that you're using the PowerShell remoting protocol, which may not be a little difficult under the hood. So you're always safe if you're an administrator. The PowerShell remoting protocol, so like for example, if you're using Test Kitchen, you should be fine here. If you don't have to be an administrator, but what you do have to do is you have to at least be in the remote management group on that machine, or in a group that's in the remote management group on that machine. The other point here, which is actually can throw you for much more of a loop, is so let's look at a server that is not domain joined. It's work group joined, and WinRM is enabled. Either you've done it manually or it was enabled by default. At the point that WinRM turns on, we've talked about it starts up the listener, it starts up the web service, it enables the firewall rules. Well, the other thing that it does, if it's work group joined, is it sets a registry key or creates it called local account token filter policy. Sets that to 1. And when that is 1, what that tells the operating system is that it's okay to authenticate remotely a local account. However, if that machine, when WinRM is enabled, is domain joined, it does not set that. So that could be very confusing, especially let's say you're playing around on a weekend, you want to test out this WinRM stuff, you fire up your, one of your, a node in your corporate environment because you have provisioning that makes that easy for you. You don't want to go to the trouble of using a domain account. You just know because on every machine, on every Windows machine, we have a built-in administrator account. So you just, what the heck, it's not production, you're going to use the built-in administrator account. You know for sure that you have the password right, and you're being told that your access is denied. And you're not being told, I'm sorry, it looks like you're using a local account. Maybe you would try, it's not at all that clear. So this is definitely something to look at if you find yourself in that situation. So we talked about what to do. Now I'm going to tell you something what not to do. It is never the right thing. I don't consider myself an absolutist, but I suppose there's like some 1%. If I was programming, if I was debugging this, I might turn on basic authentication because I want to see the credentials coming over the wire, within my own. At any rate, this isn't a good idea. Don't, unless you're really proud of your password and you want others to see it too. you're going to find documentation that's going to tell you to turn on basic authentication and to enable unencrypted traffic. Does that sound like a good idea, enabling unencrypted traffic? So it used to be that that's what you had to do. We used to not have a native NTLM. We used to not have a native NTLM library on Ruby, so we had to do this. This was the only kind of authentication we could do, and as the security workaround was basically telling people to use HTTPS. So at least that went through HTTPS. Well, now we have a working NTLM implementation. All of the major applications that use the WinRM gem by default set the authentication type to NTLM. So you have to explicitly tell it to use basic authentication. And what I'm telling you, there's never a good reason to do that. So last thing I want to talk about today. So we've managed to connect. We've managed to log in. You're doing stuff. You're deleting files. You're creating directories. Exciting stuff. And then you try to do something and it just doesn't work. But you did that same thing locally and it worked on the same node even. You did it. You can do it in RDP. So now you have to forget WinRM and do everything over RDP. That kind of sucks. So be aware that there is a small, and I really do mean that. It is quite small, but yet there's a couple significant ones in here. There's a small set of APIs that will not allow remote users to call certain methods on those APIs. And an example, probably one of the famous examples, at least it's famous to me because I could rant for 5 minutes about this, but I won't. But the Windows Update API. So you cannot install Windows updates over WinRM. It can't. Over normal WinRM, that simply can't be done. But what you can do is there is no restriction on the scheduled task APIs. So over WinRM, you can create a scheduled task and invoke a scheduled task. And what happens when you run a scheduled task? Or when the task that's being run is being run by the task scheduler, not the user that's logged in over WinRM. And the task scheduler is a local command. So I don't know, like if this was supposed to be security, protect us from security, it's not doing a very good job. But yeah, I promise not to rant about this. But I have all these people that'll listen. So anyway, yeah, we can form a circle after so anyways, we've actually created a gem that'll do just this and basically provide all the mechanics for you. So and all the applications that use the Ruby WinRM gem have a way of doing this. So for example, Test Kitchen, there is a elevated property in the WinRM settings that you can set to true. Vagrant basically does it by default. The WinRM, or excuse me, knife windows, if you're using the knife WinRM command, that shell parameter we talked about that has command or PowerShell, well, there's also elevated. So if you give it the elevated shell, any command that you run, it will create the scheduled task, it'll run the scheduled task, it'll grab onto the process that the task runs and stream its output and error stream back to the application. So to the application using the WinRM elevated gem, it has that. It's totally transparent, and it looks just like you're using WinRM, but you're actually doing it through a scheduled task. So that's all the information I have. I want to share with you these resources. This top one is a blog post I wrote a little over a year ago. I've updated it a couple times. It's kind of my troubleshooting WinRM. It has a lot of the information we just talked about today, but with more detail and with actual code that you can use. And then the last two links are the actual, enjoy these, the actual specifications, the PDFs for the WSMV. So if you want to know more, I mean, these are the Bibles for those two protocols. Maybe a good bottle of wine or some crack might get you through those. So thank you so much for listening and coming.